Welcome to the lecture series on object oriented analysis and design. So, we are looking at object oriented testing. Again, please remember that by 1995, 10 years after all the concepts have been nicely consolidated, we have not yet understood what exactly was object oriented. Object oriented was a sort of a fad. For whatever you want to do, they were prefixing with OO. It took more years, it took nearly 10 more years by the time we got to understand what exactly is OOAD, and that happened largely because we had a definition for unified modeling language and a tool support. So, it is that complexity we are understanding, it is at that complexity we see the results of object oriented in a more concrete manner. So, object oriented development and testing has these pluses. It has a nice blend of the top level phases coming in all the way to the testing phase, which is traditionally identified at a lower rung. Only after the programming phase is over, the testing phase. The practitioners speak the fact that the testing may not be a single phase, there will be two phases, unit and integration testing. We can in theory, as I said, have any number of testing, each test case costs. Once the testing phase begins, it's sort of the costing begins. Every test case has to be justified, every boundary condition has to be justified. Until then, we were in the programming phase and we were eternally stretching the programming phase. So, that is how we have been talking about. All these things have now become more and more controllable, more and more systematic. We have had the way of regulating it based on quality as the top word, only quality, nothing but quality. System same as traditional, still based on requirement specification. Obviously, how can we go out of requirement specification? You cannot tell that our requirement is to send a rocket to the moon and then we ended up sending it to the Mars. That is not the case. Two common structures used, method, class, same as traditional drivers and stubs. I mentioned all these things. So, method 1 is there, method 2 is there. We have perfected this testing thanks to the way in which we worked on object oriented. The distributed computing got a very solid basis of verifying that the remote procedure call works. We have to do that exercise. The procedures may be anywhere, the methods can be anywhere. So, what is the concern here? A message is created with the name of the method, the location of the method, initially the location of the method and the parameters. The system, the core bar, whatever you call, will locate that particular method, execute, send the results back. So, gradually we started talking about location transparency. It does not matter where it is. The genesis of the entire discussion on there are objects, tomorrow it will be things, there are things which are available. I want to do this, please let me know where are the methods, which are the methods, which are the things that will allow me to do that. So, we have had several such ideas, and then in theory, yes, it is possible that the ORB, object request broker, will locate the method, but if you know where the method is, you simply call it, give the coordinates of that method, it will call and send the result. How do we test it? That is the question. So, what we said was, in the field of object oriented, it is lot more easier to test, because you can simply test whether, how do I know whether what I am talking now is getting recorded or not. They are completely unconnected machines. How do I know it is getting recorded? There appears to be adequate machinery at the other side as much as I see here. They are talking about that camera is very polished, it looks very sophisticated. This is in this format, that is in some other form. So, it looks equally sophisticated. So, how do I know it is getting recorded? What is the test case? So, here we have one reference terminal which shows that it is what is recording is also visible to me, visible to the person at the camera, otherwise there is a strong room elsewhere. Now, we do not have to really do breaking of our heads. It is just that we have one control room or not a strong room, it is a control room where it is obvious they are monitoring it every time. If anything is not happening in between these two objects, one is the computer, the other one is a camera, and the people here will get somebody else testing that it is working. So, what we have done therefore is that the notion of checking whether the method to method communication is working or not to facilitate distributed computing has been very nicely implemented in object oriented. If two objects, the interfaces are defined, if the ideal is tested, it is doing that work. So, we found that the special features of object oriented, namely polymorphism, inheritance and encapsulation, have been very helpful in putting together objects and testing them quickly, whether they are doing what they are expected to do. Main program is minimized, most complicated part of the OO testing based on composition in bottom up approach. So, you see the point is the main program is just a list of objects, it is just that minimal. The main program simply tells that this many objects will have to come together, you name the objects, put them together, it works. This is what I have been talking about as a simple language design called Smalltalk. You are talking about modeling an aeroplane, then all the code segments are there, you touch the code segment, it will tell which part of the aeroplane it is talking about, which are the parts involved, they will appear on the Smalltalk screen. You touch the artifact, they will tell which are the objects that are there. So, it is just a minimized main program. The main program is not really talking about so much of control on these objects and how they behave in terms of methods and method interactions. Now, the point here is that we had horror stories by that 1970s, it had very good shining glories, but then many dark patches. So, Nicholas Wirth came up with this design of a language called Pascal. Pascal said that everything happens in main. It is a great discipline to talk about, nothing happens outside of the main, even if it is a one line function, two line function, all these functions written separately or together, wherever they are written, must be brought under one monolithic main, begin and end. Everything happens only between these two. It was a very good discipline. However, as we say, the language is not spoken of based on one feature. Declare before use was another very nice discipline which Pascal has introduced. Nicholas Wirth always opined the same thing, saying that the language which you are using should discipline what you are thinking and what you are coding and what you are documenting. So, the language which we are using dictates that kind of a continuum of what you are thinking, what you are coding, what you are writing, almost necessary to make sure that it is exactly as per your thought. So, what we did therefore was that the language called Pascal disciplines us like that. Very soon it gave way because the pragmatics were very difficult. The idea of separate compilation happened in C, and we do not really look at C as such a wonderfully disciplined language in any manner. The idea of separate compilation happened. You can talk about compiling, writing, test those units. The unit testing idea stems from C, whereas in Pascal there is nothing like unit testing, it is always integration testing. So, the moment we started talking about C, the influence of that language is such. What is the best advantage? C and Unix are made for one another pair kind of a thing. Therefore, we took lot of advantage from what the Unix as an operating system offered, and C and Unix have become a very good pair to address those complex pieces of software very easily. We can build application programs, we can do lot of things very quickly if we know C and Unix, they are made for one another. Now, the concern here is that from that monolithic to separate compilation, it was a choice of language, that is Pascal and C. What we are really looking at is what are the chances that the separate compilation will work. The monolithic compilation keeps on telling us that it is going to be in this manner. For that, we have been telling that there must be some kind of a main program that tells these are the separate pieces that are compiled and these are not in that compilation. It is not that we are randomly picking. However, the footprint of that main program is just an indicator saying that this many objects will have to come together, this many separate, there is a need, the semblance of a main program is necessary. Use of clusters, the ORD class dependencies or directed graphs, these are all simple techniques that we are talking about. So, there is class 1, that is there are 3 methods in class 1, in class 2 there are 3 methods, in class 3 there are 2 methods. So, what we have been trying to tell is a very simple point that there are certain message exchanges. However, what we are more interested are in the output ports. There are 2 output ports. So, what is this path? The path clearly tells that this is the way in which we connect. Where are the 2 output ports A and B? It is going via class 2, but we are not happy with halting in class 2. From class 1 we have to go very clearly to class 3. The output ports are very important. So, that is how we talked about the most important way in which we should conclude that these 3 objects are working. So, what is it that is very visibly obvious? Port A, output port A, output port B. We are quite happy to look at those outputs and go ahead if the outputs are happening, but a fully tested system will tell that class 1 to class 3 via class 2, not class 1 directly to class 3. You cannot simply test it. There is a class 2 which is hidden. The ports are not making class 2 visible, but the path should tell that the complete testing will involve all these things. There are 2 major points, that is one method which is directly connected to output port A in class 1, another method which is directly connected to output port B, and you cannot exclude class 2, and that should be told very clearly. You cannot forget, just because output port A is in class 1, output port B is in class 3, it is not enough to test class 1 and class 3 and be done with it. What happened to the middle hidden class 2? It is absolutely necessary. So, we define those paths, we have a way of looking at it. O concepts, effects on testing, encapsulation, polymorphism, inheritance. These are the 3 concepts that are making our method become so obvious. The main is skeleton. This is how we build our object oriented testing. I am not going to spend time on encapsulation as a concept. Encapsulation testing issues minimizes ripple effect of making a change. Changes are localized, faults are localized. It is encapsulated. That is why we keep telling that even though we are conscious that an enterprise typically appears as broken systems, we are very confident that that helps us minimize the ripple effect that localizes the defects. Highly delocalized change could result in significant regression testing. So, now the point is, when you are putting together these broken systems, what do? We are creating a big wrapper with some hidden objects. Now, how do we do that? We do not even know where the location is, that is a delocalized location transparency. Order of testing is very important. So, therefore, the testing phase began to become a bit more prominent, and very quickly we kept on saying that there must be dynamic binding, the binding issues of parameters, types of parameters. Again, Pascal has brought in a very good discipline called strongly typed languages. What are strongly typed languages? I know the type of the left hand side of an expression at compile time based on whatever is happening on the right hand side, a strongly typed language. So, these are, let us say I took 3 major disciplines which Pascal has ensured, almost like Hitler like disciplines. One is bring everything into monolithic, that is a main. The second one we said, the kind of declare before use, the third one strongly typed. All these have been very nice. The fourth one scoping rules. There are huge pluses. In fact, without Pascal, we would never have been disciplined as thinkers of programming. So, we said that is a very good idea, we have brought that all in. Now, we are talking about the same simple discipline based on polymorphism, which tells that the operator overloading, the same operator works for multiple types. It is almost a discipline that we have learnt from strongly typed languages. Types, type systems is a wonderful study for theoretical computer science. Testing issues, polymorphism, do you test one variant, do you test all variants? The same function is there. It is meant to do the same thing for integers, for real numbers, for complex numbers, anything. It is just a function, multiply. Are you going to test it only for integers? Are you going to test it only for real numbers? If it works for real numbers, is it adequate? Difficult questions. Again, we have to find out what exactly is the application, the criticality of that application, how much time you want to spend. The inheritance structures, the result class, how do we test for inheritance? This is what we are telling, that inherited this many attributes from two classes. Are they happening like that? Is there any other thing that is inherited? Do we have a friend function? The richness of a language is something which we need to look at, like threads in Java, it is only virtual. So, we have been talking about the attributes, inheritance. Do you completely test all base classes and their subclasses? The base classes are tested. Does it mean that a class which inherits from 3 base classes is correct? How do we know? The base classes are tested, there is nothing wrong about it, absolutely tested. What is another class which we have created, however virtual it is, which is deriving from these 3 base classes, is it correct? So, what we have been talking about is something which is very essential, and in object oriented testing, the property of inheritance tells that if there is a way of checking inheritance, then whatever you are claiming about any inherited object is correct, is working. At what levels do you test, in which order do you test? So, sorry about this color combination scenario, unit and integration. So, the point is, now we have a clear idea in object oriented, we do not have to apportion time upfront. Systems testing only this much time, unit testing only this much time, integration testing only this much time. Now, we have a seamless way of doing system, unit, integration, all the 3 covering the top level phases at the testing phase, that is after the programming is deemed complete and we are getting into the testing phase. So, we understand that the properties, the nice concepts of object oriented, polymorphism, inheritance and encapsulation have given us a simple way of apportioning our time, apportioning our work across system, integration and unit testing. If it is a method, do it at unit testing. If it is a message, event, thread, whatever it is, you can apportion it at various levels. The testing methodology based on object oriented concepts and ideas is proving to be very effective, because you can easily do it all along the entire life cycle. So, ASF atomic system function, this is where we have been talking about when there are shared resources, there must be a property called atomicity. Let us suppose there is this chair, it is a serially reusable chair, only one person can sit down in this chair. How can 2 people sit down in the same chair? So, there must be something, some control. This chair speaks for itself, that is a property of external quality factor called affordance. It will tell automatically, or all of us are familiar with chairs for so many years that one person will be sitting in the chair. In theory, there is no rule book that tells that only one person should be sitting in the chair. So, we have said that in the absence of a clarity of what is called that serially reusable resource, we need a systemic function that ensures only one process is using that resource. So, that is called atomic system function. there is no way of violating that rule. So, we created certain rule bases, they are all maintained and managed very nicely using what is called the ASF port event. Output port is not the same as ASF port. ASF input port only one person, atomic, there is an atomicity associated with that, you mark them separately. Only one will be connected to that, and therefore, we have to define them correctly. Say for example, the ATM pin entry, it is very clear that at the time of entering the pin, you must somehow ensure that exactly one person is entering the pin and that is his pin. We have had all these authentication problems, a class of authentication problems. How you authenticate is something which we will have to talk about in a separate session. These are all matters related to system security, safety. These are all the ways. Authenticity, ATM pin is a very good example. If you want, you can talk about your password. Most of the people whom I come across, they somehow think that ATM pin is the same as ATM password. They use the same terminology. Oh, this is the password for ATM, that is what they are talking about. Well, that is how the users are. So, please understand that the external quality factors are indicative of what exactly is the internal quality factor, but then it is done by the users. So, there is a card slot, you know how to give the ATM pin, but what is the guarantee? My simple question, what is the guarantee that is asking for the pin after all card processing is done? Are you seeing anything? It is asking for the pin you are giving. How do you know it is asking for the pin exactly for the purpose of activating the transaction? Nothing is known. The card is inserted, it will make some noises, some nice LEDs will glow on the ATM machine, and then it asks, it has a transactional dialog, what you want to do, depending on which brand of ATM, which bank it is, it will say now you give the pin. That is the all important number. If you give the pin, it is done, your transaction is act. Until then, we have a chance, but once the pin number is given, the transaction is there, it is all about money. So, how do you know that? We have had all these experiences. Earlier on, we were talking about the login sequence, login, password. You can in theory write a simple screen that appears as the original screen. A user in a hurry will type the username and password, you will capture and go. The story about passwords being broken, the story about PIN numbers being stolen, PIN numbers we have not been conscious about, we have not been careful, there are so many. So, we said that let there be one layer above, let these be controlled by a systems administrator. Normally, you do not forget the password, but then it is good to have somebody on top of it saying that, well, there is a cross check on the password, nobody can change the passwords very quickly. Based on passwords, lot of exercises have been written. I still remember in 1988 when I came to Chennai, I had a very senior computing professional. He has created one page to let people know how to boot the system, It was a very sought after page, just that one simple page, a clarity was there. People were finding it very difficult to understand what is this booting process, the boot record, boot floppy. It was not such an easy exercise at all. The computer itself was a puzzle, we do not know what to do with that. That is a bigger question. So, it has 20 ideas associated with that, it will ask so many things, the BIOS is tells some information is given, just one page. This is what is called the booting of the machine, a runaway success. How many people were talking about it, he himself was surprised that so many people needed it and so many people are happy about it. But anyway, it was like that, he somehow felt that he should jot down one page and it was a glowing success. It helped so many people. The quality, the external quality factors are like that most of the time. So, you have to understand very carefully that what we are looking at is something like that, saying that there is a way of authentication, there is a way of demystifying certain things. We cannot ask the user to do 3 PhDs to operate 3 times, it is simply impossible. the goal of computing flourishes when we talk about end user computing. That is what we have been talking about all along. So, towards this there has been a very nice 4 people got together and told that all these are good ideas, inheritance, polymorphism. We should have at a higher level something else other than polymorphism, other than inheritance. These are still lower level constructs. So, what they did was 4 people got together and said that there are what are called design patterns. There are certain categories of patterns. These patterns are usually found in the architecture of the system, in the design of a system. As much as you are talking about in the earlier phases which you are bringing through system, unit and integration testing, it is definitely possible to talk about 23 patterns. There are other varieties, other patterns. For so many years, we have equated intelligence to identifying the patterns. There is a regular pattern of people coming in and going. Then we know what exactly it is. It is something built over that idea called people come, people go. The pattern, if you identify, you are doing an intelligent idea. All of us borrowed that into the systems world. It is systemic, the systems view. So, we have been talking about patterns. It is not only patterns, intelligence is a bigger idea. Maybe later some other series of lectures, some colleagues of mine may be doing it, but then the fact is we need to understand very carefully that once you know that there is a pattern, you look for that pattern. If the pattern is falling in place, it is something like a bigger component. It is something like a makeup kit. You see, there is a brush, there is a comb, there is some powder here, two, 3 varieties of powders are there. There is a mirror. Now, if I put all these things in that simple kit out here, it becomes a makeup kit. So, normally if we have the discipline that we take out all these items from the makeup kit and put them, and whenever we finish, we pack all these makeup items into that kit. In an urgent method, you have to simply collect the makeup kit and go. That is the idea of a design pattern. Normally, when we want to use these, we use them separately, but then it is well prepared for making it a kit and then go. There have been so many such things. These days, people are talking about COVID-19 kits. We are talking about so many things. There is this elephantiasis kit. There are so many such medical kits, first aid kits. All of us were taught first aid kit. So, it is a pattern. Most of us require to take a first aid kit. It is always necessary we go through the rigmarole. We have to go to the even if this was true, we go to the cricket ground, we have to listen to that first aid story, and we have to go through with that method. All of us will do that rehearsal. We have to assemble very early. We do that rehearsal of going to the first aid. Only tincture benzoin was there, some cotton was there, some plaster was there, nothing much. But then all 24 people, 25 people, one by one will do that rehearsal of going to the first aid box, first aid kit, opening it, putting things back. He will tell, identify this tincture benzoin, we should identify the tincture benzoin, show that, put it in the box and come back. It is something which we need to understand, that human brain is like that, not exactly rote learning. I am not so much attuned to calling it rote learning, but repetition. Repetition of smaller exercises cements it faster. So, we talk about looking at these 23 design patterns as something which should occur. If you use them repeatedly, you will get used to it, seeing them, testing becomes faster. Thank you. We will meet in the next lecture.